Hi, my name is Bruhath and I go to Lundberg High School, and I'm going to be showing you some of the modifications I added to my smart glasses project. So one of the modifications I added was a live streaming feature. It basically shows a live feed through the Raspberry Pi camera. The second modification I added was a driver alertness system where it does two things. One, it detects the user's drowsiness by looking at their eyes and making sure that their eyes are not closed for a prolonged time. And it also ensures that the driver's head position is straight and not side to side or like distracted. So first, I'm going to show you the live streaming feature. So if I run this simple command, it gives me a link to the website where I can access the live stream. So I go to my browser and just visit the link. So this is a live feed. As you can see, my live stream. It's a live feed of what's going on through the Raspberry Pi camera. As you can see my face. You can also see my setup here. So yeah, so it's a live feed, and anybody who's connected to a network and has access to the link can view my live stream, anyone in the world. And so how this works is I basically use something called ngrok. Now ngrok, so the private server on my laptop, it's private for security reasons, but ngrok servers are public. So when I entered that command, I basically told ngrok to create a tunnel on a certain port between my server and ngrok server. It's a secure tunnel. So anytime anybody around the world goes to the link, a request is sent over the global internet to ngrok's public servers. Once ngrok receives that request, it figures out that the request is directed to my private server. So it'll forward the request through the tunnel to my laptop. My laptop will receive it and send back the HTML code, the live stream to ngrok, and then ngrok will send it to the user, and then the user's browser will display the live stream. So that's the live stream. Now I'm going to be showing you guys the driver alertness system. Um, so first, I'll be starting off with the head position. So if I run this command, um, you should be able to see my head. And as you can see, it says that I'm looking straight. However, pretend I'm driving, and suddenly I get distracted and I look to the right for too long. A buzzer should buzz. As you can see, a buzzer buzzed to get my attention back. And the second I looked back, the buzzer stopped. Even if I see something on the left and I get distracted and look for too long, it buzzes to get my attention back. The reason it takes so long for the buzzer to buzz is because when we're driving, we tend to look around a lot, and especially when we're lane changing, looking for oncoming traffic. So I wanted to make the time a lot longer to actually make sure that it was really a distraction and not something that we need to do in order to drive safely. So as part of the driver alertness system, not only is it head position, but as I said, it's also eye detection. So now I'll be just displaying the eye detection. So as you can see, when it loads, you can see that it says my eyes are open. But let's say I'm driving and suddenly I get sleepy and all of a sudden I close my eyes for too long. The buzzer will alert to get my attention again because it's not safe to drive when you're drowsy, right? So those are my two modifications. Now I'm going to explain how the driver alertness system works. So essentially what I did was I used something called MediaPipe, which is a machine learning framework that was developed by Google. And as part of that machine learning framework, there's a module called FaceMesh. Now what FaceMesh does is it creates a map of our face. A map as in it gets different coordinates for different features of our face. For example, there's a coordinate for our chin, coordinate for our nose. There's a bunch of coordinates around our mouth, around the eyes, this side, etc. And these coordinates are 3-digit or 2-digit numbers. It's all basically a very detailed map of our face. And all I did, for example, for the head turn, all I did was I essentially, in my code, I got the coordinate of this side of my face and this side of my face. I did a simple calculation to get the midpoint, and this midpoint stays stationary. And all I did was I took the nose landmark, and to determine if the person's head is turning right or left, I basically calculated the displacement between the nose landmark and the midpoint. For example, if I turn to the right, the midpoint is here, but my nose landmark is here. So if this displacement is either positive or negative, it will determine it as the person is turning their head to the right or to the left. And then I said, oh, if they're turning their head right to the left for a certain amount of time, then sound the buzzer. It's a similar thing, similar idea with the eye detection model. What I did for the eye detection model is I used something called the eye aspect ratio. The eye aspect ratio is a ratio between the vertical distance of our eyes and the horizontal distance of our eyes. And how it works is if that ratio crosses a certain threshold, it's determined that this person's eyes are closed. So all I did was I implemented that idea into my code, and I said, oh, if the user's eyes are closed for a certain amount of time, then it'll say, oh, this person's eyes are closed, so that means we have to buzz the buzzer to get their alertness. So that's how my modifications worked. For my next steps, I'm probably going to, add this all onto my portfolio and really give a good explanation for how it works. And some of the challenges for these were actually figuring out what to do. Prior to adding this modification, I knew I wanted to do some sort of alertness system, but I wasn't sure how to do it. So researching and figuring out that, oh, something called face mesh really exists was definitely the most trickiest aspect of my modification. Thank you.